Hey, so we're going to do lesson 16, or at least parts of it, and some parts of lesson 17 today. So I'm going to wait a few seconds for everyone to quiet down so people can hear this video. And also, you should have your book already open to lesson 16, and you should have a ruler in front of you too. We're going to use ruler all the time for a while now. Please try to refrain from slapping them all the time and bending them in a way that you know is kind of damaging them. All right, so I'm gonna wait. All right. So before we actually get into lesson 16, I want to sort of tell you exactly what the lesson is all about. So we're doing these things called scale drawings. Scale drawings are an application of proportional relationships. They're a way that people actually use them in real life. So here's like a definition of scale drawings that I made. It's probably about the same as the one that's in your book. It says, a new drawing is a scale drawing of an original drawing if there is a proportional relationship between the side lengths of the original, which we'll always think of as x. Our original drawing's side lengths will always be x, and the corresponding side lengths of the new drawing, which we'll always think of those side lengths as y. So original is a, and new is y. And we have this word corresponding that I think you'll understand what I mean by when I say corresponding side lengths after I do this example here. Essentially, scale drawings are a way that proportionality is used in art and animation and architecture and engineering to make sure that shapes sort of retain their shape when you make them bigger or smaller to use them in different applications. So let's look at these two drawings that I have here, just a couple of simple rectangles. I labeled the vertical sides in blue for both drawings and the horizontal sides in orange for both drawings. And a question that you might see in the book or on a quiz is drawing B, the new drawing, a scale drawing of drawing A, the original? And the way you check is there a proportional relationship between all these sides? Hopefully you can kind of see that there is just by looking at these numbers, but let me show you the way you would actually do it. So we would usually make a table. You don't have to be doing this right now. You can just be kind of watching. And I would call these my original. Over here I could put original for the original drawing, or I could put drawing A. Both of those would be okay. And maybe remind myself that these are X. And then over here, I could put my new, or drawing B, or remind myself that these are Y. And then I'm gonna put corresponding sides next to each other in the table. So I have this side length from drawing A, and that corresponds to this side length that's also in blue over here in drawing B. So 1 for drawing A and 2 for drawing B. That's coming from here and here. And I could do these side lengths as well, but they're obviously the same, so I'm going to save myself that work. And then I'm going to do the orange lengths. I have 1.5 for drawing A and 3 for drawing B. And then the way we check whether or not these drawings are scale drawings of each other, or more technically, whether the drawing B is a scale drawing of drawing A, is nothing new compared to what we've been doing. I'm just gonna make a new column in my table. I'm gonna call it my y divided by x column, surprise, surprise. And I'm gonna check whether or not these ratios are the same for each one. 2 divided by 1 is 2. 3 divided by 1.5 is also 2. And so this tells me that there is a proportional relationship between the side lengths of drawing A and drawing B. And so we say, yes, drawing B is a scale drawing of drawing A. And normally I would ask you, when you find a proportional relationship, say what the K is. Well, we have it, it's right here, but we don't call it K when we're dealing with scale drawings. It gets a new name. It's still the constant of proportionality, but we call it the scale factor. all this will start to make more and more sense as we do this more, I'm sure. So here's just an example of two drawings that would not be scale drawings. So this is the same rectangle I had on the previous page, side length of 1 inch by a horizontal side length of 1.5. And we could call this I meant to call this the original. The original, and we could call it drawing A. And we could call this the new and call it drawing B. And just by looking at it right away, you can see how this one is more long horizontally, and this one essentially turned out like a square. It was supposed to be a perfect square, but I don't know, I messed up on this line a little bit. So you could tell just by looking at it, something's out of proportion is what people say in real life. And that's just a way of saying there's not a proportional relationship here. But we can check it just to be sure, just to see how it's supposed to be done. We make a column and call these our A values, or remind ourselves that it's X. Call these our B values, or remind ourselves that those are Y. So these values will come from this drawing. These values will come from this drawing. And we put corresponding side lengths next to each other. So I've got 1 and 3 in blue. And I've got 1.5 and 3 in orange. And then we make a new column in our table, and we could call it B divided by A, or we call it Y divided by X. It doesn't really matter. I'll call it Y divided by X. And 3 divided by 1 is 3, but 3 divided by 1.5 is 2. So we would say no, drawing B is not a scale drawing of drawing A. All right, so that's pretty much the whole idea of the next few lessons we're doing. Let's take a look at lesson 16. Lesson 16 is pretty much the easiest lesson in the entire book. There's not even really a ton of math to be done here, but we can learn a few vocab terms and see some examples of things. So here you have what is a shrunken subway map. And that's an example of a time when you might scale something down, as they say, right? You wouldn't make a map that's the actual size of the subway. You'd make a small one that could be hung on a wall or something, or inside the BART car. And then here is an example of something that would get scaled up, or lots of times in real life we say it gets blown up. If like a police investigator needed to look at a thumbprint, they might want to see a bigger version of it so they could see the details. So this is, well, these have names actually. When you shrink something down, you make it smaller, that's called a reduction. So this poster here would be an example of a reduction. And when you scale something up or make it bigger, that's called an enlargement. These are important vocab terms. You guys got to know these. You only call things a reduction or an enlargement if they are scale drawings of whatever they came from, though. If things are out of scale, like if you go back to this example where this square wasn't a scale drawing of this rectangle, you would not call this an enlargement of this because it's not to scale, so it doesn't get that term. But in the first example, when this rectangle was a scale drawing of this one, you would call this an enlargement. So it has to be a scale drawing in order to be called an enlargement or a reduction. All right, so assume that these are scale drawings and these are scale drawings. Take a second to label whether these are enlargements or reductions based on what they tell you here under example 1. This should be super easy. I'm literally just going to give you like 1 minute. You can talk with the people at your group. Enlargement or reduction for the B picture in each of these. All right, so I want your attention back in 4, 3, 2, 1. All right, so hopefully you read the directions. It says that the A picture in both of these examples is the original. Well, all right, I'm noticing that the book likes the word actual. I say original, same thing. And B is, well, they call it the drawing. I always say the new drawing. So sorry, I should have clarified that terminology a little bit before I got you started on that. But A is the actual or original, B is the new, and so this is obviously an enlargement of A. So you would call this one an enlargement. And then for this one, B is obviously like smaller than A, so you would call this one a reduction, or you would say it's reduced. It doesn't matter which way you say it. All right, let's flip the page. We're gonna go ahead and skip this. This thing's a little weird, and I don't think it's gonna help us much in what we're really trying to get at today. This, on the other hand, is kind of fun. So I don't know if it's the mathiest thing we're ever gonna do in my class, but I don't know. It's just kind of a cool thing to spend a couple minutes doing. So one way that you can guarantee you're gonna make a nice scale drawing, a good enlargement or reduction, is by using grid spaces. We won't always have grid spaces to help us. Most of our scale drawings are going to be done by measuring with a ruler, and we're going to have to learn to be really precise and accurate with these things. But to get us started, what I want you to do is you choose. You can either make a reduction of this robot by just copying the number of boxes for all the lines into here. And as long as you use the same number of boxes for all the different pieces that make up the robot in this grid space, then you'll wind up with a perfectly to-scale reduction of the robot. If you do the same thing but over here in the larger grid space, you will get a perfectly to-scale, or a scale drawing, as they say, enlargement of the robot. I don't want to take the time for everyone to do both, to do the reduction and the enlargement. That's a lot of time. Even just making one can take a few minutes in and of itself. So you pick. Either you are going to do the reduction or you are going to do the enlargement by just, plotting points based on this drawing over here and then using your ruler to connect them. I will give you, I think, 5 minutes is fair. If you get one or the other done in that 5 minutes, then if you get the reduction done and you still have time, then you can do the enlargement or vice versa. All right, let me get you guys' attention back, please. I'll wait a few seconds for people to quiet down. All right, so while you were working, I went ahead and made the enlargement. And I don't know if you can see it, if the camera is zoomed in enough, but I made a little mistake as I was doing. I was plotting dots. I started up here in this corner of the robot, and then because he has 4 boxes across top of his head, I went 1, 2, 3, 4, and then I tried to go down to like where his neck meets his body or whatever, and I counted down 4 and over 1. So I just plotted points and then essentially played connect the dots at the end. But as you can see, I miscounted at first and put some dots in the wrong spot. But luckily I hadn't connected the lines yet, so I was able to fix it. So, all right. So yeah. So the grids help us make a nice 2-scale or scale drawing enlargement. Let's flip the page, and now these questions are essentially asking us to do what I was showing in that example from the first page before we even started the lesson. They want you to look at some drawing, make notes on the dimensions, the side lengths in a table, and then see whether or not it's proportional. So let's just do one of these examples. I don't want to spend a ton of time doing both. So let's go to the triangle one down at the bottom. Let's count the side lengths of the vertical side. So these two sides of this triangle, of these two triangles, are corresponding. And so if we call, well, let's read the words here, because the words will help us figure out which of these triangles they want us to consider the original, which would be our x values, and which one is the second or the new image, which would be our y. So it says, Luca drew and cut out a small right triangle for a mosaic piece he was creating for art class. His mother liked the mosaic piece and asked if he could create a larger one for the living room. Okay, so it sounds to me like the small one he did first, and then he's trying to create a larger one. So we should treat this as original, or x, and we should treat this as new, or I guess I should have said second, and y. All right, so this side length in the original is 5, and that's the height. And that same side length in the new is 15, so that's the height of the new. So right now, I'm thinking y divided by x is 15 divided by 5. So, you should be able to do that in your head, but you should have an idea of what this k or this scale factor needs to come out to in order to be scale drawing. So the width of each triangle. So that would be the bottom, the base here, 1, 2, 3 on that triangle. And then, let's see here, this looks like 5, 10. So the width of the small one, the original, is 3, and the width of the second one, the bigger one, is 10. And now if I'm thinking about making a new row on this table here and calling it y divided by x, well, 15 divided by 5 is 3, but 10 divided by 3, that's, 10 thirds, which equals 3 1/3. These aren't equal. So these two look like they're almost to scale. They almost look proportionate to each other, but the base of this one's ever so slightly too big, and so it's just out of scale, we would say. So fill in the table. Does a constant of proportionality exist? No. The y over x ratios are not equal. So is Luca's enlarged mosaic a scale drawing of the first image? I don't even like the fact that they've used the word enlarged here, because my understanding is that you don't really call something a true enlargement or reduction unless it actually is to scale. And we would say, no, it is not a scale drawing because Normally we'd say because there's no k, or because the y over x ratios aren't equal. This time let's say because there is no scale factor. That's essentially the same as saying there's no k, but we're just using a new word for k, which is scale factor. All right, let's move on into lesson 17. So we're skipping a bunch of pages here. Homework helper, problem set. All right, this is where it gets pretty serious. Let's look at Jake's logo here. I'll wait a few seconds to make sure everybody got to the right page and everybody's focused and ready and all that stuff. I'm gonna get a bunch of different colored markers out of here. All right, so lesson 17 says, Jake created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that Jake wanted to create a distinctive icon so that players could easily identify his game. So apparently his distinctive icon turned out to just be a cube. Good job, Jake. All right, so continuing on, it says, he drew a simple sketch. From the sketch, he created stickers to promote his game. But Jake wasn't quite sure if the stickers were proportional to his original sketch. So, all right, so this is his original sketch of his cube icon. So we'll call it X. And here's the sticker. That's sort of like our new, right? Well, this is the thing we're checking to see if it's to scale or if it's a scale drawing of this one. So let's call it our Y values. And then let's just mark off corresponding sides from this one to this one and add them to the table. First, let me label the parts of the table. So I'll write original. I like to abbreviate original as orig all the time, so you kind of just get used to that. And then, I know it says sticker, but I kind of like new better. So I'm gonna call this new Y. And then I have a bunch of colors to work with here that's gonna make this look nice. You probably don't. If you do, you can use them. So I'm gonna start with this side right here, and I'm gonna mark it as pink, and I'm gonna mark its corresponding side over here, also in pink. And so for the original, it's 7/8 of an inch. I'm not gonna bother putting the inch in here though, I'm just gonna put numbers. And over here it's 1 3/4. I'm gonna just go ahead and do a little bit of conversion and say 4 times 1 is 4, plus the 3 on top is 7. So I'm gonna call that 7/4. And I'll call that a row in my table. And then let me get a new color. So I've got this side down here where it says 0.75. They're being jerks to us in this book by giving us fractions, mixed numbers, and decimals all in the same little exercise here, but we'll deal with it. We got it, no problem. So for the original, this side here is 0.75, and the new is 1.5. All right, and let's do another one. Let's see here, I'll use orange for this side here, and its corresponding side here. And so for the original, it's 1, and for the new, the corresponding side length is 2. And then let's go with this one for the last side. This one is also 1 inch, and its corresponding side length is also 2. Do we have to put that in the table since we already have a 1 and a corresponding 2? Maybe not, but let's just be thorough and do 1 and 2 again. All right, and so our whole job here is to see whether or not his sticker or his new thing is a scale drawing of his original. So we're just checking to see whether or not there's a proportional relationship here. So I'm going to draw a new column onto the table. I'm going to call it the y divided by x column. And then I'm going to let you guys do a little bit of work. So you need to do some decimal division here. Obviously, these bottom two are really easy. Maybe a cube change flip or some other strategy for that top one. And check, see if you get all the same ratios here and whether or not this is proportional. I don't feel like this should be too hard from this point, so about 3 minutes I think should be enough. Help each other, please. Okay, let me get your attention back in 3, 2, 1. All right, so while you were working, I started to do a keep change flip to do my y divided by x here in pink. And if you were watching me, you might have been laughing at me because I accidentally started making the mistake of doing x divided by y here, and I got like part of the way through it, and then I realized, wait, I messed up. And you know what I could have done is just completed this calculation and then just flipped my answer at the end. But I don't know, I feel like I was embarrassed, so I just crossed it out real quick. And I did it the right way. I did 7/4 divided by 7/8. Keep change flip, that's 7/4 times 8 over 7. I got 56 over 28, which I know is 2. So this ratio is a 2. I think it's pretty easy to see that these are also 2, right? 2 divided by 1. And so we just need to do this last one. I hope you didn't run for a calculator too quickly. You could have just converted 0.75 to 3/4 as a fraction, and 1.5 to 1.5. And so then what you're really trying to do is, well, 2 times 1 is 2 plus this 1 on top. That's 3/2 divided by 3/4. Keep change flip that. 3/2 times 4 over 3. You get 12 over 6. That indeed is 2. 12 divided by 6 is 2. So all these ratios came out to be 2. That tells us there's a proportional relationship between these corresponding side lengths. And so we say, yes, the sticker is a scale drawing of the original. And we always state the scale factor. When we have a scale drawing, we say the scale factor, and it is 2. A scale factor of 2 essentially just means you're making something 2 times bigger, right? The scale factor just tells you how much bigger something's going to be. If the scale factor came out to be 3, then you're making something 3 times bigger. If the scale factor is 10, you're making something 10 times bigger. When you have little scale factors that are smaller than 1, then you're actually making something smaller. If you have a scale factor of 1/2, then you're making something half its original size. If you have a scale factor of 1/4, then you're making something 1/4 its original size. So we're going to write out a little 3-step process here to check for proportionality, to see if something is a scale drawing of an original picture. So step 1 is identify corresponding side lengths. Right, so what I mean by that is, I'll leave this here for you to copy for a few seconds, but in a moment I'm going to flip to the previous page to show you what I mean by that. So here, I had to know that this side length corresponds with this one in pink, and the blue corresponds with the blue, and the purple corresponds with the purple. Like, you have to make sure that the sides like go together, they match. Then you record corresponding values in an XY table, not a graph, but a table, just like we've been doing. And then third, just like you would a proportional relationship, just check if all y divided by x ratios are equal. And if they are, then you have a scale drawing, and that number that keeps popping up is your scale factor. So essentially everything I just said is the stuff that's here in the key idea, so we don't need to read that. And I'm not a big fan of this exercise 1 app icon, so instead, let's look at these flags. I do like drawing these flags. And there's something important here that I can show you when it comes to these flags. They want us to use a scale factor of 3 to create a scale drawing of the picture below, and this is a picture of the flag of Colombia. What we have to do is actually measure the side lengths of this flag, not only the sides, like the vertical side here and the horizontal side along the top or the bottom, but also we have to know what is the distance just for this really light gray part at the top. Let me put some color on mine so it's easier to talk about what I'm talking about. I'm gonna call this I wish I knew the actual colors of the flag of Colombia. I should, I don't. So I apologize if I'm offending anyone by putting the wrong colors in here right now. Let's call the top part the blue part, the middle part the pink part, and the bottom part the orange part. And so you have to know how tall is the blue part, and how tall is the pink part, and how tall is the orange part. So there's a lot of measuring to do here, and you need to be precise. Your ability to measure precise with a ruler is going to be really important for this entire section of what we're doing in this class. So let's talk about some things. The first thing you should do is find the first mark on your ruler and line that up very nicely with the edge of whatever you're trying to measure. Don't line up the end of the ruler like I'm doing right now, because then you have this extra gap here before the actual measurement part of the ruler starts. So you have to line up that first line. Next thing you want to do is be looking directly over where you're measuring. Like I'm standing looking straight down at my paper right now. When I'm sitting like I am right now, I'm looking at things at sort of an angle, and it can make my perspective incorrect and make me make mistakes in my measurements. So it's important that you look straight on. When I look at this right now, I can see that from top to bottom, this whole flag on this paper is 1 inch. That's super convenient for me. And this book did that for me on purpose. They purposely made it a perfect inch. This book and the things I give you on quizzes will almost always be really easy to measure one way or the other. What I mean when I say one way or the other, I mean either with the inch side of the ruler, the side where the numbers are farther apart, or the centimeter side, the metric side, where the numbers are closer together. You should measure with both sides and see which one's going to be easier for any given scale drawing. If I were to line this up with the metric side of the ruler this time, I look at it and I would say it's about 2.5 centimeters, but it's sort of between the 2.5 and the 2.6. And that just feels like it would be harder to me to deal with a 2.5 or a 2.6 here on this side than a nice clean 1. So that tells me that it's advantageous to me to do this question in inches. So I'm going to label the fact that this whole side length from top to bottom here is 1 inch. I'm not going to use a bunch of space though. I'm going to try to keep it close, because we're going to use a scale factor of 3 to make a new flag in this area. And so you got to use like almost this entire area is how it winds up being. You might even wind up turning it and making it up and down. It's kind of hard to fit on the page, to be honest. And now I'm going to measure the top here. And it's kind of hard because the book is curled, but it looks like a perfect 1.5 inch to me. Remember, we practiced how to measure with the inch side of the ruler a few weeks ago. Every little line is 1/16, and the longer the line is, then the smaller the denominator of its portion of an inch that it represents. The littlest lines are 16ths, the next biggest are 8ths, the next biggest are 4ths, and the kind of long ones right in the middle of the actual inches are halves. So this is 1.5 inch here. And then if we reline up on the side, we see that the blue part is 1/2 inch. So I'm going to put 1/2 over here. I'm going to save space and just put the numbers. And that the other half is taken up evenly by the pink part and the orange part. And so that means they must both be a nice 1/4 inch. And so if we have to use a scale factor of 3 to make our new drawing, we should make a table, but let's not take up any of this space right here, because this is where our drawing is going to go. So I'm going to maybe put my table way up here. I'm going to call this the original, and I'm going to call this the new. The original will be these measurements that I just took, and the new will be the dimensions of this new one, this big one that I'm going to draw here. So original is 1/2, 1/4, 1, and I'm going to write 1.5 as 3 halves. So because 2 times 1 is 2, plus 1 is 3, so 3 halves. And then since I'm using a scale factor of 3, I just multiply all of these numbers by 3, and that's how big the side on my new flag needs to be. So 1/2 times 3 is 3 halves, but you can write that as 1.5. So that's going to be the blue part, the height of the blue part. 1/4 times 3 is just 3/4. So that will be the height of both the pink and the orange parts. 1 times 3 is 3. So that'll be the height of the whole new flag. And then 1.5 or 3 halves times 3, well, that's 9 halves, but that's the same as 4.5. And so this new flag you're going to draw, this new scale drawing flag, is going to be 4.5 inches wide. And so you got to make sure that you can fit 4.5 inches across here. And what I would do is draw your first 4.5 inch line way down at the bottom, because you also have to make it 3 inches tall, and you want to make sure you have that space. So I'm going to draw a 4.5 inch line across here, and I'm going to let you have whatever's left of the period to do as much of this as possible. I'm imagining there's probably only like 1 or 2 minutes left in the period. You get as much of this big flag done as you can, and then we'll continue on here probably tomorrow. See ya.